Okay, in order to calibrate the spectrometer, we need to collect two different sets of spectra with our phone. The first one will be collected with the incandescent bulb, which is the broadband source. So this sort of simulates the sun, where we get more or less constant distribution of wavelengths over the visible range of light. And we need to use that to collect the spectrum, and then we'll replace that with a compact fluorescent light bulb, which has discrete atomic emissions or line emissions, where we know exactly what frequency or what wavelength those emit over. That'll allow us to calibrate the wavelength scale on our phone. So I'm going to walk you through both of those steps. Start by flipping on the incandescent bulb. It's going to make it a little hard to see in this video. And then switch to camera mode on your phone. Go ahead and line that back up and attach it to your Velcro. So it should look something like that. Get it on there nice like this. There's a little bit of a glare. Sorry about that. Click on the actual spectrum here, just to get it as sharp as possible. That looks pretty good. And so we're gonna, once you get it nice and focused where you want it, I'm gonna press capture and I'm gonna collect that image. Alright, I'll give you a quick pro tip here. When you're collecting your spectrum, you want to make sure your camera is positioned in a way where the red and the blue portions of the spectrum are all included here, which is going to be sort of a function of the camera positioning. A couple of things that help in getting nice spectra are making sure you're focused on the spectrum area and not on another region within the field of view. This entire camera frame is could be focused on different areas of the image. So most phones allow you to click on a certain area and focus. So I could click there, that's a really bad one. I could click here. It starts to get a little bit better. And then what can help is when you click, often it's not just auto-focusing, but it's also auto-exposing, meaning it's changing the gain settings on the sensor itself to change the brightness. And so it can help to decrease the brightness. And to do that, you can often, there's a setting in your phone, it may be different in different places, but you can decrease the brightness, and you can see how that really improves the quality of your spectrum, simply because of where the relative brightnesses are between the reflected objects and the spectrum itself. I'll give you, since this surface here in the image, that's the mirror inside the housing of your spectrometer, and then these bright spots right on the red side, those are actually the bottoms of the cuvette, and since they're transparent plastic, they're reflecting light, and your camera's picking that up, and then it's scaling the intensity of the image based on that. And so decreasing the brightness here can significantly improve. So those are a couple pro tips to help you get the best image. After you capture the first spectrum with the broadband incandescent bulb, go ahead and power off your lamp. This bulb and this housing are going to be far too hot to touch for several minutes. So you're going to want to let that sit for a bit and wait until it's cool enough to touch. They're really, really hot, hot enough to burn your skin. So be really careful at this point. So next you want to grab your compact fluorescent bulb after you've allowed your incandescent bulb to cool and you've removed it from the socket of your lamp. Go ahead and grab your lamp and very carefully thread that in to the socket like that. Again, nice loose touch, don't crank this down, just finger tight like that, and go ahead and position your lamp approximately the same distance that you had before. A ruler can be nice, but you don't really need a ruler, just a sheet of paper with a couple lines on it so that you're consistent will be good enough. Okay, go ahead and turn the power on to your compact fluorescent source. What we can see here, and I'm going to need to focus back on there. So So you can see pretty distinct difference from what we saw in our continuum source or our broadband incandescent source. Now we have very discrete bands of light here. Those bands are coming from the atomic emission of red, green, and blue lines that are strategically engineered into the compact fluorescent light to give you the perception of white light, even though it's not the true white light, which has a continuum of colors between it. You're only seeing those three discrete bands, and then your eyes are fooled into thinking that is white. So what we're going to do is these red, green, and blue bands of light that are being emitted by this compact fluorescent, I will measure their exact frequencies using a spectrometer here at Colorado College. I'll provide you with those wavelengths in nanometers, and then you'll be able to use those exact positions to then calibrate the wavelength of your particular cell phone camera. So that's what we're going to do in this calibration.